Salutations! Today we're going to be continuing our discussion by talking about Faraday's law. Faraday's law is a situation in which we can calculate the mathematical quantity of electrons or current that are involved in a electrolysis or an electrochem process. So this whole thing we're going to be wanting to be thinking about moles. You want to keep thinking back to moles. So you know how we have electrons transferring happening in electrochem, right? Like that's something that we know. Oxidation reduction that involves electron transfer. So Faraday's laws teach us how to quantify the amount of electrons or the flow of the electrons or the time it takes for the electrons to transfer. Lots of different things. A couple of things that we need to get down before we can go forward. Understand that we're going to be measuring things in a couple of new units. We have something called a coulomb. And we have what's called Faraday's constant, 96,500 coulombs, which can be abbreviated by the letter C, equal 1 mole of electrons. Now, we also call this a Faraday. So, in other words, like 96500 C over 1 mole, that equals 1 Faraday. But we're really not going to be calling it Faradays. We're really going to be focusing more on this and less on this. We're going to be focusing on that relationship between coulombs and moles. Understand also that we can use this relationship between coulombs and moles and connect it to a thing called current, which is measured in ampere. Ampere, or just a capital A, we also just use a capital A for ampere. Ampere is 1 coulomb per second. So the relationship is here, coulombs per second. So you might be able to kind of see the connection here, that there is a connection between coulombs and moles, right? Because 1 coulomb is coulombs per mole, right? So 1 coulomb equals 1 mole. I should write that instead of coulombs per mole. So that equals 1 mole of electrons. So we have this connection, right? So if I was given moles of electrons, I can work my way back to amperes. If I'm given amps, I can work my way to moles. And if I've been in moles, I can get to grams. So there's a little bit of a connection here, and that's what we're going to be doing in our practice today. So it's a lot of practice work. So let's just dive right in. You'll see that mostly this is just unit conversions. There's really nothing more complicated than that. It's just kind of understanding where we start and what we want. So let's look at a couple problems. Let's look at number 15. Now understand that these are straight from your book. All I did was pull the text straight from your book. If you don't want to write this out into your note packet, you are welcome to refer to your book, page 676. But if you'd like to have the text in your note packet, you might want to pause and write these problems down. And then we will work through them. Okay, so let's look at 15. It says, how many grams of silver metal will be deposited by a current of 1 amp flowing for 9,650 seconds? So let's kind of take stock of what we have and what we want. What we have is current. And what we want is grams of silver metal. So let's think about what's happening here. It says how many grams of silver metal will be deposited, meaning that the silver metal is gaining mass. If we think about a half reaction that shows this, the half reaction would probably look something like this, right? And we are gaining mass. So this is important to write this step first because we're going to be really interested in the ratios between the electrons and everything else. So let me kind of show you how we set this up. We're going to probably start with either the seconds or the amps, right? So they give us the amps, but we are going to use the seconds to take the amps and turn them into moles. So we're going to start by using the seconds. So this is 9,650 seconds. And let's think about the relationships that we have. We have seconds and coulombs. So let's use that, right? That's right here, coulombs and seconds. So I know that for every 1 second, I have 1 coulomb. So this is what an amp is, right? Coulombs per second is an amp. I'm just writing out this value here. So amp is coulombs per second. So now I'm going to take my amps and I'm going to convert my amps into moles. I know that I can get rid of my coulombs by using this value, and that equals 1 mole of electrons. Now, I have a connection between moles of electrons and moles of silver. That's what I'm interested in, right? I have that up here. For every 1 mole of electron, I have 1 mole of silver. So for every 1 mole of electron, I have 1 mole of silver. And then finally, it's asking me for grams, so I'm going to take 1 mole of silver, and I'm going to use molar mass to find grams. And the answer you should get for this is about 10.8 grams of silver. So if you follow the thought process through, let's kind of run back and make sure that we know what's going on. So I started with the seconds, and I multiplied my seconds by my amps to give me coulombs, right? Seconds are multiplied, I get coulombs. Once I have coulombs, I multiply coulombs by Faraday's constant, which is that 96,500, and that gives me moles of electrons. I then take the moles of electrons and I look at my balanced half reaction. I don't need the full redox reaction for this, just the half reaction. And I use that to go from moles of electrons to moles of silver. And then I go from moles of silver to grams of silver, and bada boom, bada bing, I got to where I needed to go. All right, so let's look at another one. Let's look at 16. This one says a current of 5 amps flows through a cell for 10 minutes. How many grams of silver could be deposited during this time? Start by writing the cathode reaction. So the cathode reaction is the reaction that we wrote before. The Ag plus 1 electron gives us Ag metal. So this is very similar in design. This time you're going from minutes, however, to grams. So I'm going to let you try this one on your own because it's really similar to the last one. Go ahead and give it a pause, set it up, and come on back when you're done. All right, hopefully this is what you did. So it's really very similar to the previous step, except now instead of 1 amp, I have 5 amps, and I started in minutes. So I have to take minutes and get them into seconds first. And then as soon as I'm in seconds, I just run through it the same way I had before. So let's kind of make sure that we're all on the same page. Minutes go to seconds, seconds go to coulombs, coulombs go to moles of electrons go to silver moles go to grams, just like that. So it's just really long form unit conversions. It's not anything that you haven't seen before. You just have to know what units to use to convert into what you want. So let's look at another one. What current must be used to plate 1.75 moles of copper on an electrode in 6.24 minutes? So let's make a couple assumptions here. Let's just assume that the copper that they're talking about is copper plus 2. So let's just make this assumption. It'll make the problem a little more straightforward. So we're assuming that we're dealing with copper 2, but this is a little different this time, right? This time they are looking for current. So the thing I'm interested in is amps. And I am given moles, and I'm given time. So remember the equation. Amps equal coulombs per second. So if I can figure out coulombs and if I can figure out seconds, I can solve for amps. You are given moles, which you can use moles to get into coulombs, and you are given seconds, or excuse me, you're given minutes, which you can use to get to seconds. So I think I might let you try this one. Pause it and see if you can find out coulombs and seconds, and then divide them against each other, and that should give you amps. Come on back when you're done. Okay, so I decided to do mine all in one shot, but if you'd like to do it in separate pieces, then that's okay. But notice that all I did was I took my moles of copper and I converted it into coulombs using Faraday's constant. And then I took my minutes and converted them into seconds. And now I have coulombs over seconds, which is an amp. I just divide those numbers and I get 902 amps. So let's look at 18. 18's a little different this time. We are now looking for time and we are given other things. So it says what period of time in hours was required if a current of 5 amps was passed through a salt or sodium chloride solution and 1 mole of chlorine was produced. So think about the reaction that's happening here. We have, oh, getting ahead of myself. We have chlorine producing Cl2, right? So if it's going from chlorine minus to Cl2, then it must be losing electrons. This means it's oxidizing. So we want to balance this real quick like that. And then we would be good. So we're going to use that equation. And again, think about this equation up here, this A equals C over S. The thing that we're mysterious about this time, or I don't know why I said mysterious about, the thing that we're wondering is what's the time, right? So manipulate the equation as best you can to solve for seconds. I'm going to let you try this one out again because it's a lot of the same. But this time now you're solving for seconds. Go ahead and give it a try and come on back when you're done. Okay, so now that we have solved for the thing that we are mysterious over, we have 1 mole of chlorine, which we turn into coulombs. And then the thing on the bottom here, the coulombs per second, this is just an amp. So I'm just multiplying, or excuse me, I'm just dividing by amps. So when I have coulombs on the top and amps on the bottom, it gives me seconds. If you're kind of curious about how to do that, whenever you have to solve for anything that's in the denominator, you just flip them. So the equation that I'm solving for is seconds equals coulombs over amps, and that will give me seconds. And in fact, it does. It gives me 38,600 seconds, but the question asked me for hours, so I'm going to just convert that into hours. All right, one more. Now this one I'm going to let you do by yourself completely. So start by writing the half reaction like we have for each one. This time we are talking about calcium. So we are trying to deposit calcium, meaning that we are gaining calcium, right? We are gaining more solid calcium. So start with the half reaction, figure out what you want, figure out what you need, figure out what you have, and calculate for your answer. Give it a try. Come on back when you finish. Okay, so hopefully you were able to interpret from the problem that you were again looking for time. This time you were looking for seconds. So again, we use the same sort of equation that we made last time. Seconds equal amps, or excuse me, seconds equal coulombs over amps. We want to start though by writing out the half reaction. So that's calcium plus 2 electrons give us calcium. And if you're wondering like, well geez, how did you figure that out? Just look at the wording that's happening in the problem. It's saying that we are depositing grams of calcium from the cell, meaning that we are gaining calcium, right? And if we're gaining calcium, then that means that calcium must be reduced. It's gaining electrons. So that is the reduction half reaction for calcium. And remember, the only reason we need this is because it tells us the ratio between electrons and the calcium metal. So which we use for the coulombs, right? We go from grams of calcium to moles of calcium to moles of electrons, and then finally into coulombs. So then we have coulombs over amps. That gives us seconds. We convert that into 7.65 minutes. And that's it. So it's just, like I said, it's a lot of unit conversions and mostly just manipulating that equation for amps. Amps equals coulombs over seconds. It's nothing you haven't seen before. It's nothing you're not capable of. It's just a couple new little things. That's all for this video, and that's all for electrochem. Easy. We'll see you next time.